Coin change. You are given an integer array, coins, representing coins of different denominations and an integer amount representing a total amount of money. Return the fewest number of coins that you need to make up for that amount. If that amount of money cannot be made up by any combination of the coins, return -1. You may assume that you have infinite number of each kind of coin. So basically they have given us coins and they have given us amount. So you want to make how many coins are needed to make the amount of total 11. So when they have given 1 to 5, you need 3 coins to make the amount 11. That is 5 plus 5 plus 1. You need 2 coins of 5 and 1 coin of amount 1. At when you total those, you get 11, and that is the fewest coins which you have needed. Like 2 plus 5 cannot happen 11, 1 plus 5 cannot, so coins cannot be happening. That's the reason you need uh, 3 coins, 2 of amount 5 and 1 coin of amount 1, and total comes to 11. And how many coins are there in all needed? 3 coins. Let's take the next example. Coins of amount 2 and the total amount given is 3. Now you cannot make it, right? You have just $2 with you. How can you make $3, right? So that's the reason we are sending the output as -1. Basically, these coins, uh, you have a coin 1 with amount 1, coin with amount 2, and coin 5 having an amount 5, right? So you have infinite numbers, means 1 also you have infinite numbers of coin with amount 1, 2 also infinite numbers of coins with amount 2, 5 also infinite numbers. So you can take double five or triple five, or you can take double two or triple two, whichever you needed to make up that particular amount. Here input is they have given coin amount with 1 and amount is 0, so you need just 0 coin. That's the question. So basically, to understand this question, it's important to know that, usually what we do if this question comes, like suppose we have coins of 1, 3, 4, 5, right, and amount is 7. So usually what we do, we go and check which is the biggest coin. That's our mentality, right? The brute force way. What we do is, we just check, okay, my amount is 7 and I have this 1, 3, 4, and 5 coin. So let me take the highest coin, highest amount coin. So I'll take 5, and then I'll just go ahead and check, is 5 plus 4 7? No. Is 5 plus 3 7? No. Is 5 plus 1 is equal to 7? No. So I will try to make up the amount of 7, right? So what I will do with 5, I'll add with 4, 3, and then I'll come and add with 1. So 5 plus 1 becomes 6. So I'll add 1. I need 1 coin. Then again I will try to, I want to make 7, right? So I'll again iterate in my array and check, like, is there any coin which will help me to make up till 7? And yes, we have the coin 1 and coin, all these coins are infinite numbers, I can use it. So I will again add 1, and that gives me the answer 7. But so how many, in this approach, whatever I told you right now, which is like a very brute force approach, or because you have highest amount, so you'll take a highest number and try to add it and try to come to a total amount, that is 7. So you require 3 coins with this particular approach, right? You require 3 coins, 1 coin of 5, 1 coin of 1 amount, and another coin also of 1 amount. Now, but if you observe carefully, 3 plus 4 also becomes 7. So if you take a coin of 3 and if you take a coin of 4, then that will give you the answer of 7. And in this approach you get a coins only 2, and they have told us they need a minimum coins. How many minimum coins are needed to make the amount 7? That is what is the question. That's the reason we cannot use this approach. This approach is called as a greedy approach. What is it called? It's a greedy approach. Just a little bit about greedy, I told you. It's like you have to take care of the highest one first and then go ahead and check other if it is, you can solve the solution with this particular approach or not. So greedy because we took the highest amount and try to solve our problem, but we cannot use it because with this greedy approach we have seen that we require 3 coins, and actual answer is 3 plus 4, that is 7, and only 2 coins were needed. So we cannot use this approach. Now let's try to think what is the next approach we can use for this particular sum. So the next approach is backtracking or a DFS, right? That's the next approach because we need to make different combinations. So whatever our sum was, so our sum was 1, 3, 4, 5, right? So I will take coin of 1, I'll take coin of 3, I'll take coin of 4, and I'll take coin of 5, right? I'll try to make the combinations like can it give me total amount of 7, right? Total amount is 7, right? Total amount is 7. So I will try to understand, like if I take coin of 5, let's go from behind, so I will able to explain you more faster. uh, DFS is nothing like back or front, it's just simple, but I'm just taking 5 just to make you understand faster. So if I to take amount of 5, right, so what I'll do, I will just minus it. 7 minus 5 is how much? 7 minus 5 is 2. So here the remaining amount is 2. So we have to make amount 2 now, right? We have to make amount 2. 7 minus 4 is 3. We have to make amount 3 now. Then 7 minus 3 is 4, and 7 minus 1 is 6, right? Now just try to make 2. How much 2? So for we have to make amount 2, right? So here also I'll try to take all these combinations of coins and try to check whether I can come up to the solution. So I'll take 1 coin, I'll take 3 coin, again I'll take 4 coin, and again I'll take 5 coin. So if I take this coins, then I'll again check. See 5 here. See 5 is 1 coin, 1 is 1 coin. 5 plus 1, 6. 7 minus 6, that is 7 minus 6 is how much? 1. So I need only 1 coin. After this, I need only 1 coin. After next step is, so I need only 1 coin. Next here is 5 plus 3. What is 5 plus 3? 8, right? So it is going ahead of our total amount. Our total amount is 7. It is going ahead of our total amount. So we have to give the negative one. That is what is given in the question. 5 plus 4 is 9. So again negative. 5 plus 5 is 10. Again negative. So here again I can take one coin and come to a zero amount, right? I can come to a zero amount. So this is one of the approach which I got it. This is one of the approach which I got it to make my amount 7. What is the approach? 5 plus 1 plus 1. This is one of the approach which I got it to make the amount 7. So how many coins are needed? You see here 3 coins, 5, 1 and 1. Now same thing, whatever I did this decision tree, same decision tree I'll go ahead and make it under 6, under 4, under 3. So let me show you what I'm trying to say over here. Now let's go ahead and try to make a decision tree for the 6, right? Try to make a decision tree for 6. So here I'll take coin of 1, 3, 4 and 5. Now as you know, this is coin of 1, right? This is a coin of 1. Remaining is 6. Here we have a remaining of 6. So when I take 1, So when I take 1, 5 is pending, 5 amount is pending, then 3 is pending, because see, 1 plus 3, 4, 7 minus 4 is how much? 3. So 3 is pending here, 2 will be pending, and here 1 will be pending. Now you observe carefully, when we come to 5, we are again going to take 1, 3, 4 and 5, right? Again we are going to solve the same equation. This is 5, this was also 5. See here, this was also 5. We are going to again repeat our steps, right? When we have taken the coin 5, what we have done? 2, 1 and 1. Again same method will be over here, because this is 5, and then again we have to take the same amount. We have taken same coin 1, so again here it will be 2 pending. Same equation will go ahead as we did in this part. Same thing with here, when we have taken 3 coins or 4 coins or 5 coins, whatever equations we are doing, we will be doing the same equation as what we did it in this place. Also, when I do it here, right, when I do it here or when I do it here, although we'll get a answer at this 3 and 4, but the solving method, I don't have a place to solve it, but the solving method will be repeated, because we are solving here 3 and 4, we are solving here 3 and 4. Even if you see whatever I marked green, we have solved the coin of 5, and we have got the coin, we have got the amount of 5 with one coin, and we are trying to solve the same equation which we solved earlier. That's the reason we are repeating the steps. This is called as repetition of the steps. So we are unable to use this method, because we are just going to take more longer time the if we start using DFS or a backtracking. This approach is called as top-down approach, where we are trying to solve the problems into sub-problems and come to a conclusion, but the work is a lot of repeated. So what is the next method which we can use for our 1, 3, 4, 5 coins when amount is 7, right? What different method I can use? We can use a DP approach, that is a dynamic programming approach, where I can say, first I will create a DP, and then I will say, okay, let's have DP of 0. DP is an array which I will be creating, and I will fill that array following things, like if the first I'll fill that particular array with 7, all entire array will be 7. Then I'll fill one by one the equation. See, if I want to make amount of 0, consider, if I want to make amount of 0, how many coins I need 0 coins, right? If I and 0 coins are needed, no coins. If I want to make amount of 1, DP of 1, that is amount of 1, out of this, which coins are needed? Do I need 5 coin with amount of 5? No, because amount is 1, right? So how much I needed? Do I need 4? Do I need 3? I need only 1. So I need a 1 coin. Then DP of 2. DP of 2. Here is a catch again. Do you see any coin with amount of 2? No, we don't have any amount of coin which is with 2. So of course we need this 1 coin. So 1 coin, this 1 coin is already needed, plus additional coin is of 1 is needed. So I'll write 1 plus. Now, how to make this 1 coin? I have already made it, I have already used it. So I can use it. See, I'm not repeating the step. I'm just going to use this coin, help to make amount of 2. So I will be using DP of 2. Sorry, DP of 1. Because I have already created that DP of 1 as 1 coin. So I will be just trying to use the same amount. Here we are not repeating, we are using whatever we have done is. Now, if I have to create amount of DP of 3, what will I do? See, here we have a coin DP of 3, so I can easily use that and I need only one coin of DP of 3 to make amount 3, right? How many coins are needed? Only one. Here you see in DP of 2, how many coins are needed? 2 coins are needed, because one coin is one of the additional and DP of 1 is coming from here. Now DP of 4, want to make amount of 4, so how many coins are needed? Only one. See here, DP 4, we have 4 number 1, we have a coin with amount 4, so we need only one coin. Now let's take DP of 5, we also need one coin. See here we have that coin. DP of 6, right? DP of 6. So for 6, do we have a 6 coins here? No, we don't have a DP of we don't have 6 coin. So what we have to do, obviously we have to take this one coin, a DP of 5, because it's 1, and we just have to add one more coin. That's a DP of 5. That's become DP of 6, right? If you add 1, because already you have 5 coin and you just add 1, so 1 plus 5 is again 6, so you come to a conclusion. Now the catch is in making the coin of 7, DP of 7. I'll just rub this part because this is still DP of 6. I want to make you understand DP of 7, which is an important part. So 1, 3, 4, 5 and 7. So let's make DP of 7. Here there is a catch, okay? There are a lot of solutions for this DP of 7. I will be initializing minimum coins needed, okay? Minimum coins needed. So let's try to check DP of 7. If I take the solution will be I can take DP of 6, which I have already made. That is one of the solution. I have made DP of 6, right? And I'll just add one coin, that is DP of 6. So if you see DP of 6 in the back, when you see DP of 6, we needed 2 coins. And this is one more coin. So the total becomes 3, right? 3 coins. DP of 6, which I made it earlier, was 2. 2 coins needed to make DP of 6. That's the reason the coins needed to make DP of 7 is 3 coins. Now the minimum coins I will update with 3. Next solution is what? DP of 7 can be made by using number 4 also. If you see, if I use DP of 7, we can use with the help of one coin of DP of 4 and one coin of DP of 3. So 1 plus DP of 4, this is one solution. So you need 2 coins over here. Another solution is DP of 7. Again, you can take one coin of DP of 3 and one coin of DP of 4. So again, one solution, 2 coins needed, right? If you see, you can take one coin of this and one coin of this, right? So 2 coins needed and you get the solution 2 coins. Or you can say in this fashion as well, like you need, if you see, sorry for my such bad. So here it was, one second, let me write it again. So here it was 1, 3, 4, 5, right? And amount is 7. And minimum coins we had was 3, right? So now again, the solution is DP of 7. You need DP of 3 and you need DP of 4, right? So each one, if you see at the back, DP of 3 is formed by one coin and DP of 4 is formed by one coin. So total 2 coins needed. So that's how we get an answer, because we are going to update 3 to 2 coins and we get an answer. So you can come to an answer by using whatever you have made earlier. So this approach is something like we can use this approach, the DP approach, we can use it because we are coming to a total amount of 7. by using the DP approach, that is called as a bottom up approach, where that is also called as a dynamic programming approach. Simple idea of dynamic programming is you are storing some information with you in that DP array and you're reusing that information in a sequential manner. And that is a very important approach, or you can use it to solve your solution. And this will be the time complexity wise also, it is just O of amount, that is O of n, and space is O of n because we are creating an array. So this is a good approach because we come to a conclusion at a faster, right? So let's see the solution for this TP approach. Okay, so here if you see, I have already written the solution wherein I am taking the coins and I'm taking the amount. And this is the base condition where I say if amount is where amount is less than 0 or coins dot length itself is 0, coins are null, then we just are returning 0. We are creating a DP array and we are taking amount plus 1 because we are starting from 0 indexing, and that array I'm filling it with DP and that particular amount. I'm assigning DP of 0 as 0. We know why it is 0. If you want to make 0 amount, it is 0. I'm going to iterate with the next index to the amount array, and I'm also going to iterate to the coins array. So coins over here was 1345, amount was 7. So I will be iterating over here as 1, 2, 3, 4, 5, 6, 7. I will be iterating till the amount 7. Same over here, the coins which I had was 1, 3, 4, 5, right? So I will be iterating this amount coins array, and then I am checking, I'm always doing a minus of the coins. If you see my method, I'm always, if 7 is coming and if I'm taking a 3, then I'm going to minus that particular 7 minus 3, how much is pending, 7 minus 4, how much is pending, and that way we are coming to a conclusion. So that's the reason I've written this condition. And when it comes to DPFI, we are taking the minimum coins of the first by itself, and then I'm taking 1 plus dp of I minus coin, the same thing which I showed you that if I want to make dp of 7, then see, just show you again. If I want to make dp of 7, exactly what I need is 1 plus dp of 7 minus 4. Suppose I'm taking coin of 4, right? So 7 minus 4 is 3. So I need coins like this, right? So in all, I need 2 coins. And this is called recurrence relation. This is the only one line which is important, which we are repeating over and over again and coming to a conclusion. And this will be helpful because we are filling our array already, so we can get what is dp of 3, only one coin. So total number of coins are 2 which are needed, and then we return the amount. And if there is no amount, if we are not getting the amount, then we are returning minus 1. This is again a base condition. So if there is no default value, then we have to give some minus 1. And time complexity is O of n, and space is also O of n. Thank you.